Welcome back, everyone. We are up to lessons 25 and 26 of Unit 2. These are the last two lessons of Unit 2. And what these are about are finding the sum of the first whatever terms of a geometric sequence. You might be asking yourself, why are we doing this in Unit 2? We talked about geometric sequences in Unit 1. The reason is being that the formula for the sum ends up being a rational function. So it fits right in with this unit. This is our formula right here. So A is our initial or our starting value. R is our common ratio. That's the value being multiplied by each time. And N is the number of terms that we're looking for, and we're looking to find the sum of. So a couple of things. When the common ratio is a percentage, the R value is the decimal form of the percent. So in other words, for example, if the common ratio is 20%, the R value is 0.20. If it's 5%, it's 0.05, so on and so forth. Except in the following context, when you're earning interest on investments or bank accounts. The R value would not be the percentage, it would be 1 plus the percentage. So instead of 0.05 for 5%, it would be 1.05, so on and so forth. So let's take a look at the two examples that we have here. Number 1, Brandon is prescribed a course of antibiotics for an infection. He is told to take a 150 milligram dose of the antibiotic regularly every 12 hours for 15 days. He learns that only 5% of the medicine is still in his body after 12 hours. Based on this information, how much of the medicine will be in Brandon's body at the end of the 15 days? So what I'm first going to do is I'm going to write the formula. And then let's go ahead and fill it in. So A is my initial or starting value. In this case, my initial value is how much medicine does he take initially, and that's the 150 milligrams. R is going to be the percentage. In this case, it's the 5%. We do not need to do 1 plus the percentage because we're not talking about investments. So my R value is going to be 0.05. So that is my R. My N value here is how many doses is Brandon taking? Well, he's taking the antibiotic every 12 hours for 15 days. So the question you have to ask yourself is every 12 hours is how many times per day? Well, if there's 24 hours in a day, then every 12 hours would be twice a day. So essentially, he's taking the dose twice a day for 15 days, which means he's taking a total of 30 doses of this medicine. So the N value in this case is actually going to be 30 because he is taking a total of 30 doses. Every 12 hours is twice a day. So it'll be 150 times 1 minus 0.05 to the power of 30 divided by 1 minus 0.05. One minus 0.05. So let's go ahead and find this answer. So we're going to just put this in Desmos. So it's going to be 150 times 1 minus 0.05 to the power of 30 divided by 1 minus 0.05. Okay? So the answer in this case is going to be 158 milligrams if we round it. So how much medicine is going to be in his body at the end of the 15 days? It's going to be 158 milligrams. Okay. Number 2, Denise decides to open a bank account that earns interest at an annual rate of 2%. If she deposits $100 into the account at the beginning of each year, how much money will be in Denise's account at the start of the 50th year? So let's again write out our formula. So our initial value in this case is going to be the initial deposit. So that's going to be $100. 1 minus my R value, because it's an investment, it's going to be 1 plus the percentage. So in this case, it'll be 1 plus 0.02 or 1.02. My N value in this case is going to be 50 since we're looking for the 50th year. So what we're going to calculate looks something like this. Okay? So again, A is the $100 initial deposit. R is 1.02, 1 plus the percentage. And the N value in this case is going to be 50 since we're looking for the total at the start of the 50th year. So it's going to be 100 times 1 minus 1.02 to the power of 50. Divided by 1 minus 1.02. And we end up with $8,457.94. $8,457.94. So that is the total that will be in her account at the end of the 50th year. And that is it for lessons 25 and 26.